This video is for ELEC 1510 Logic Design. This is Lecture 14, Part 2 on the D latch, corresponding to textbook section 5.3. The previous video was about SR latches, set-reset latches, and eventually we built up to the SR latch with enable. The circuit diagram for the SR latch with enable is shown here on the left, which has 4 NAND gates in one possible construction, 3 inputs, S for set, EN for enable, R for reset, and the outputs Q and Q prime, where Q prime in stable states is the complement of Q. The truth table here shows the behavior of the circuit for different values of the inputs. Just to review, when enable is a 0, it doesn't matter what S and R is. Q is going to hang on to its previous state, whatever that was set to previously by S and R. If enable is a 1 and set and reset are both 0, again there's no change in the output. Q and Q prime will remember its previous state. When enable is a 1 and set is a 0 and reset is a 1, that means Q is a 0 and Q prime is a 1. That's one of the behaviors at the output that you can set. When enable is a 1, set is a 1, and reset is a 0, that means that the output Q is a 1 and Q prime is a 0. That's another one of the outputs that you can set. When enable is a 1 and set and reset are both 1s, there's an indeterminate unstable state created at the output, and that's called an illegal condition, and we avoid that condition. A D latch is made up of an SR latch with enable here, connected in a different way, where we have an enable line that is just directly connected to the enable line of the SR latch with enable, and then a D line where D stands for data, where D is directly connected to S, so S equals D, and is connected through an inverter, which I've created here out of a NAND gate, so that R is equal to D prime. So let's discuss the behavior of a D latch. I'm going to first configure the S and R inputs as intermediate variables in this circuit as combinations of D and enable. So I'll fill in all possible values for D and enable. So because S is equal to D and R is equal to D prime, when D is a 0, R will be a 1. When D is a 1, R will be a 0. When D is a 0, S will be a 0, and when D is a 1, S will be a 1. When enable is a 0, we know from the behavior of the SR latch with enable that Q and Q prime don't change. So it doesn't matter what the S and R are set to by D, Q and Q prime still don't change. So that holds true for 2 rows in this truth table. Now when enable is a 1 and set is a 0 and reset is a 1, set to by D being a 0 right here, that means that Q is a 0 and Q prime is a 1. When enable is a 1 and D is a 1, that's this row here, S is a 1 and R is a 0, meaning that Q is 1 and Q prime is 0. The D latch is more simply drawn as just a block here, with D and enable as the inputs, Q and Q prime as the outputs, and the truth table given here with just D and enable. When enable is a 0, it doesn't matter what D is. Q hangs on to its previous state. It doesn't change. When enable is a 1, Q is simply equal to D, and Q prime is equal to D prime. We can set it to the data that we enter into the D latch, and then by setting enable to 0, it will remember that data, even if the D line changes.